Hey everybody, this is your 7-4 trig identities. So why we're studying this, why you're studying this, is in this lesson you'll learn algebra concepts related to trig functions. There are many trig identities you have to become familiar with, including when you solve for one expression in a Pythagorean identity. So like for example, we talked about this another time, but if you have sine squared plus cosine squared equal 1, then sine squared would be 1 minus cosine squared. And if you have cosine squared, that's 1 minus sine squared. So that means this one Pythagorean identity turns into 3. So these Pythagorean identities are right here. Like on this one, you could solve for tan squared or solve for 1. This one you could solve for cotan squared or solve for 1. So these 3 could really turn into 9 identities. Word problems related to this would be about searchlights and optical measurements. But you basically want to use algebra to simplify trig expressions and establish identities, which means like proofs, kind of like geometry. Two functions f and g are identical if they're equal for every value where they're defined. That's called an identity. An equation that's not an identity is a conditional equation. Like for example, if x equal a certain number, then the equation is true. Like if x equal 2, then 3x minus 1 is 3 times 2 minus 1, which is 5. So that's what we're talking about. Like on the condition x is 2, it's 5. If it's not 2, it's undefined. If x is not 2, it's undefined. And that would that 2, 5 would correspond to the ordered pair 2, 5. The other things you'll remember is your quotient identities. Remember, quotient involves division, and its tan is sine over cosine, and cotan is cosine over sine. Now, reciprocal also involves division, but it's the 1 over. Like cosecant and sine are inverses, so it's 1 over. Secant and cosine are inverses, cotan and tan are inverses. Then here's your Pythagorean identities again. So those are typed out for you. Here's your even odd identities. I mean, basically I just typed everything that was on here for you. So these are called the basic trig identities. These should not just be memorized, but known and understood. In fact, various minor variations are used, like solving for one of them. For this reason, among others, you need to know these relationships and be comfortable with variations of them. So your guidelines are going to be to start with the more complicated side, rewrite it as a single quotient, and sometimes write in terms of only sine or cosine, which would help. So if you saw secant, put it in terms of cosine, etc. Always keep your goal in mind. As you manipulate or change one side, you have to keep the other side the way it was, and you want to make them match. Okay, so let's get started. So with this one, we have cotangent times secant. So cotangent, I'm going to put x instead of theta. Cotan x, secant x. So secant is 1 over cosine. So I did that first. Now, because of that, I got a choice. I want to guide you through this. Like, if you saw cotangent x, you could think, well, 1 over tan x or cosine x over sine x. And because I did secant first, and you see there's a cosine there, that means I want to use this form of it. So at this point, I'm just going to keep it the same. And then I'm going to put cosine x over sine x, and then 1 over cosine x. So now you can cross these out because one's on top, one's on bottom, and you get 1 over sine x. Now, they want your answer to be in terms of sine and cosine, so not cosecant x, which actually is correct, but they want it in terms of sine and cosine, so that's your answer. Now, on this one, they want you to multiply by this. Remember, if something's the same on top and bottom, it's like multiplying by 1. And so that's why it's legal, like it is allowed. But what you got to do is distribute this, and then you're going to have to do FOIL on these. So if we do sine times 1, we're going to get sine x. Sine times negative cosine is negative sine x, cosine x. And if we do 1 times 1, it's 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine. Now that's actually canceling. If you have a negative and a positive of the same thing, they are going to cancel. Just like if you had 1 minus 3x, 1 plus 3x, that'd be 1 minus 9x squared, because your 3x minus 3x cancels. Okay, so your middle terms are going to cancel. Then on this part, we get cosine times negative cosine is negative cosine squared. Now at this point, what you're going to want to do is factor out your GCF. That's the lowest thing in common. So if you have sine x and this expression, you got to factor out your sine x. And so you'd be left with 1 minus cosine x. Now on this one, you've got 1 minus cosine squared x. And again, what we said was that's the same thing as saying sine squared x. And that's since sine squared x plus cosine squared x equal 1. If you move it over, that's your Pythagorean identity. And so this whole denominator gets replaced with sine squared. Now, after you do that, then you cancel this sine with a 2, and so that's how you get your answer. 1 minus cosine x, or you say cosine theta, and then sine x, which is sine theta. So that's how that works. Now on this one, they want you to get a common denominator. So your common denominator would have to be the product of cosine and sine, which is sine cosine. So how you have to do that, let me take some steps on this. On this one, if you have cosine x minus sine x over cosine x, and sine x plus cosine x over sine x, they want you to get a common denominator, and so the common denominator would be cosine x times sine x. Now, because this part already has cosine, but it doesn't have sine here, you got to multiply sine times this. And this part doesn't have cosine, so we've got to say minus cosine x times sine x plus cosine x. So that's off to the right start. And now you got to distribute here and distribute here. Sine x cosine x minus sine x squared, or sine squared x, and then minus cosine x sine x minus cosine squared x over, by the way, cosine x sine x is usually written with the sine first. It really doesn't matter. So you can reverse that. And also, speaking of reversing it, this term and this term are positive and negative of the same thing. So those go away. Now, didn't we have a Pythagorean identity with squareds? Yeah. If you factor out a negative, you get sine squared x plus cosine squared x, and then sine x cosine x. And wasn't this just equal to 1? Yes, it is. So this is negative 1 over sine theta cosine theta. That's your answer. So that's all the work for it. Now on this one, they want you to multiply and simplify. So for this one, maybe I should have done this on paper, but that's okay. Sine x cosine x over cosine x plus sine x cosine x plus sine x minus 1. So far, all I've done is I wrote down the problem using x instead of theta. So that's what the problem is. Now keep your numerator the same and do cosine times cosine is cosine squared. One of these plus the other gives you 2. So plus 2 cosine x sine x, and then plus sine squared. And then there's a minus 1. Now, guess what? Cosine squared x plus sine squared x is 1. Because that's like somewhere else, right there. Cosine squared x plus sine squared x is 1. So that's substitution. And so then you have sine x cosine x on top. And 2, I'll go ahead and put it in the other form, sine x cosine x. Now those cancel and you are left with just a half. Because earlier when I did this, if this is 1 and then minus 1, 1 minus 1 cancels. And this was since cosine squared x plus sine squared x equal 1. So that's how come you get a half. Now on this one, you're going to have to factor, and if you want to use u equal cosine theta, if you want to, so it's 6u squared plus 5u plus 1 over 3u squared plus 3u plus 1. If you don't want to use u, you can. I mean, you don't have to, like, do whatever is best for you. If I have it like this, we're going to have to get the product, which is 6, and this term has to be positive. So I've got to use a 3u and a 2u. And if we have a 1 here, I've got to use a 1 and a 1. So this would be 3 plus 2 is 5. So that is going to be correct. And then on this one, you've got to use 3u and 1 and a u. 3u plus u is 4u. Okay, that did not work for the denominator. So if that didn't work for the denominator, what if we took out 3u plus 1? I'm sorry, what if we took out 3u, then you have u plus 1, and then there's also a plus 1. Because this way didn't work, and so if you just do the GCF of those two terms, that's what you get. And what I just noticed, and this is my bad, there's a 2 here, not a 3. And so that threw me off a little bit when I was doing this. This should have been easier. It's like 2u plus 1, u plus 1. Because 2u times u is 2u squared. 2u plus 1u is 3u. 1 times 1 is 1. So that's easier than you think. And then this and this cancel out. And so you have your 3u plus 1. Now we said u was cosine. So that's how they have cosine. 3 cosine theta plus 1 over the u plus 1, which is cosine theta plus 1. So that looks messy, but it actually was easy. I just made a little, I read it wrong. The 2 goes here, not a 3. And so that's what you get. Okay, let's try one more. It says establish the identity, which means do the proof. So the first thing is write the left side in terms of sine and cosine. You keep this the same, and then cosecant is the same as 1 over sine. And then it says write it as a single fraction. So you do cosine times 1 is cosine and put sine on the bottom. And then it says that turned into cotangent using what? The quotient identity. So that's a couple of problems with that. We'll continue more in the next video.